Alright, so today we're going to be learning what I consider a fairly simple lesson, because as long as you can graph sine and cosine, you can graph secant and cosecant. So these are on pages 51 and 52, and this is lesson 22, graph secant and cosecant. And I didn't give you a foldable today because there's not really a reason. We're just going to write down some steps, and then I'm going to show you a diagram at the end. So to graph secant and cosecant, you're going to first of all graph the reciprocal function. So if you're graphing secant, then the reciprocal is going to be cosine. And if you're graphing cosecant, then the graph that you're going to first create is sine. Once you've done that, and that's the hard part, the second step is draw asymptotes at each x-intercept of the reciprocal. The third step, a max of the reciprocal is a min of the function. So a max of the reciprocal is a min of the function. And then the reverse is also true. A min of the reciprocal is a max of the function. So all those words may not mean a lot to you at the moment, so I'm going to draw a parent function. Okay, let's do cosecant. So down below, draw yourself a nice big graph, big being long ways. So it looks like that. And go ahead and draw another one, and we'll do both secant and cosecant. So this top one, let's put our equation, y equals cosecant of x. So the first step says to graph the reciprocal function. And remember, we talked about the reciprocal of cosecant is sine. So we're just going to start by graphing the sine function. And here we have an a of 1, our b is 1, we have no c and d. We recognize that the reciprocal of this is just the sine parent function, which all of you at this point should have memorized. So our amplitude is 1 and -1. Our period is going to be from 0 to 2 pi. So I'm going to put in those three values between 0 and 2 pi. So pi is halfway in between these two, pi over 2 is halfway between there, and 3 pi over 2 is halfway in between here. Okay, and actually for the sake of our notes, I'm going to also draw another period in this direction to the left. So -2 pi, halfway in between that's -pi, halfway between those, -pi over 2, and halfway between -2 pi and -pi is -3 pi over 2. So the reason why I've plotted all these is so now we can graph our sine function. We know that it starts at the origin and goes up, comes back down, dips down below the center, and then comes back up to the center. So this is 1/2 of the sine function. But I want to extend it in the opposite direction. So it's going to go down, up, back down. And you can see that it's oscillating back and forth, repeating for forever around that x-axis. Okay, so that is that's our parent function of sine. But now we have to follow the rest of the steps to actually do cosecant. So we're going to draw an asymptote at each x-intercept of the reciprocal. I'm going to color code this. So we're going to draw asymptotes at each x-intercept. So where are x-intercepts? Well, that's where we cross the x-axis. So at all of these points, we're just going to draw asymptotes. Okay, so looking weird so far. Remember, this sine function is not actually part of our graph. It's just there to help us graph cosecant more quickly. Step 3, a max of the reciprocal is a min of the function. So I'm going to highlight all of the maxes of the reciprocals, which are going to be mins of our function. So we got this, and we would have one over here. And then the min of our reciprocal, here and here, are going to become the max of our function. Well, what on earth does that mean? Well, it's actually quite simple. Here's what it does. You draw little bitty parabolas with mins at each of the orange spots, what were previously maxes. And then you draw little upside down parabolas at all the pink spots. The ones that were originally mins are now maxes. So, to make this clear, our actual function, because now I've got highlighting all over the place, kind of looks confusing. Our actual function is going to be this blue here. And see how they stay within the asymptotes? So the blue is our function. And what we can actually do here is erase our sine function entirely. And voila. This is what you would get if you typed it into a calculator. You'd get like this gap in the middle and then these little parabolas going everywhere. Alright, so now let's go ahead and in the next video we're going to do secant.